Hi there, welcome to Smart Way of Learning Concepts and Enjoy Learning. Hi there, welcome to Smart Way of Learning Concepts and Enjoy Learning. In this video, we are going to gain some insight into a full wave rectifier with a capacitor filter. This circuit is a full wave rectifier with a capacitor filter. Transformer primary voltage is denoted by Vp and it is given as Vp equal 100 sin 2 pi ft. And from the turns ratio, the transformer secondary voltages are found using this formula. It is found that both secondary voltages have same amplitude and it is half the primary voltage. So this is the transformer secondary voltage Vs1, which is a sine wave with a peak voltage of 50 volts and with frequency of 1000 Hz. So its time period would be 1 millisecond and half the period will be 0.5 millisecond and 1/4 the period will be 0.25 millisecond, which is also equal to the peak time Tp. This is the output of full wave rectifier without capacitor filter. And this is the output with capacitor filter, and it is also the voltage across capacitor. The red colored dotted lines is the actual response and green colored line is the approximate assumption made to simplify the analysis. But to answer the given question, we need to consider the actual response, and now let us see why the actual response is exponentially decreasing in nature. Let's assume that capacitor is initially relaxed, so that the initial capacitor voltage is equal to 0. During the first quarter of first half cycle, Vs1 is greater than capacitor voltage Vc, so the diode conducts and it is in on state. Since it is given that transformer and diode are ideal, the resistance offered by them is equal to 0. So the capacitor charges in proportion with Vs1 till the end of first quarter of first half cycle. So the voltage across capacitor at the end of first quarter, that is at T/4, will be equal to peak voltage of 50 volts. And now during the second quarter of first half cycle, Vc will be greater than Vs1. So the diode is off and the capacitor stops charging. Now the capacitor has an open switch on one side and load resistance on the other side. So the capacitor tries to discharge through the load resistance till Vc decreases below Vs1. Again during the first quarter of second half cycle, when Vc decreases below Vs1, the diode conducts and the capacitor voltage charges in proportion with Vs1 once again, but now with initial voltage of Va. Similarly, when the Vc is greater than Vs1, diode would go into off state and the capacitor discharges through load resistance. The analysis remains same for remaining cycles. Here from P to A or from P to B, the capacitor is discharging, and we know the very basic that capacitor discharges exponentially. So this is the reason why the actual response from P to A is exponentially decreasing in nature. Now coming to the given problem, it is given that the ripple content in the output is 5%. What it means is that the output variation is limited to within 5% of its peak voltage. With this information at hand, the voltage at point A is nothing but decreasing peak voltage by 5%. 5% of 50 is 2.5 and subtracting 2.5 from 50, we get 47.5. From the figure, Va and Vb are at same potential. Va equal to Vb equal 47.5 volts. The time required by the Vs1 to reach Va is denoted by Ta, and this time is found by equating Vs1 to 47.5 volts, and it is found to be 0.2 millisecond. And the time required to reach peak voltage, that is 50 volts, is nothing but 1/4 of the time period, and it is found to be 0.25 millisecond. Or it can also be found by equating Vs1 to 50 volts. From this figure, we can write these following relations. Tc equal Tp minus Ta. If we know Ta and Tp, we can find charging time Tc. The sum of charging and discharging times is equal to half the period. From this relation, we can find Td, since Tc and half the period are known quantities. And the potential at point B is equal to peak voltage into exponential of minus Td by RL into C. And from this relation, all are known quantities except C. And it is found to be approximately 8.8 microfarad. If you like my video, then hit on the like button down there and subscribe for interesting updates. Thanks for watching. Have a great time.